Okay, today we will move to the another topic. This is one of the very important topic, relational databases. The relational databases. Now we'll see how I want to make the work for you. This is, I want to upload the material first. So, relational databases. Relational databases. This is doesn't come to the mechanism yet. See, load recording is fine. The material I want to send you. This is yes. This should be the one, I think. That is not the one. Where is this material? Go ahead here. Then the material. Share the material first. Should be this. Exactly. Here. Always I think material is this one. I suppose you can see it. If not, just tell us. I'm going to record the work. Now this is what I want to talk to you today. This is definitely another new topic. It's called relational databases. One of the very important chapter and very important topic in accounting information system. The databases and files. Under this topic, you will learn many things. You can see here the many things here. One is explain the importance and advantages of databases. Explain the difference between logical and physical views of the databases. Explain the fundamental concepts of databases systems. describe what a relational database is, and create set of well-structured tables, especially for databases, and perform simple queries with using a Microsoft Access database. We'll start with the databases. What is databases? It is important to understand how data are stored in a computer system. As in accounting information system is a computer based today. Then how accounting information, how accounting data going to insert to the computers, you should want to understand. Usually you can see in this diagram, the data are, databases are like a hierarchy, top to bottom approach. Information about the attributes of a customer, such as name, address, are stored in the fields. That is the way in computer we store and we save data about the customers, suppliers, employees, and about the transaction, like a fields. All fields containing data about one entity. Example, for one customer's name, address, telephone numbers, etc. So one field. It's all enter into the field as a record. A set of related records, such as all customers' records, we call a file. A set of interrelated, centrally coordinated data files that are stored with as little data redundancy as possible forms a database. A database consolidates records previously stored in a separate files into a common pool and serves a variety of users and data processing applications. Databases were developed to address the proliferations of master files. For many years, companies created new files and programs each time a need for information arose. You can see in this diagram database, customer files, sales files, inventory files, you can see. Then customer file, record 1, customer 1, record 2, customer 2, record 3, customer 3, etc. You have customer N. Then each customer, take as a customer 2 his name, his number, customer name, street address, city, state, zip codes. You can see this is the basis elements of a data file. Now efficiently and centrally correlates information for a related group of files we call database. A file is a related groups of records. Now is file, right? You can see file, customer file, all related records. Then file including so many records. You can see here. The record is a related groups of field. That is field. It's all records. Record 1, 2, 3, customer 1, 2, 3. Those are we call field. Field. Similar field together, it's a customer file. The field is a specific attributes of interest of the entity, right? Every field have a particular person's whole information. Now that is the way the computer already record all data into the databases that are inside the computer. You can see carefully this chart. In the database approach, data is an organizational resources that is used by and managed for the entire organization. not just the originating document. A database management system is the program today, is a program that manages and controls the data and the interfaces between the data and the application programs that use the data stored in a database. The database, the DBMS, and the application programs that access the database through the DBMS. DBMS means Database Management System. System we call DBMS, right? Are referred to as a database system. The person handling database system we call database administrator is responsible for coordinating, controlling, and managing the database. Now you can get a clear idea. There are some advantages of databases. Now you can see the list here. Data is integrated and easy to share. Minimize data redundancy. No duplication arises. Data is independent of the programs that use the data. Data is easily accessed for reporting and cross-functional analysis. See how these connections, right? The integration. What's data integration? Master files are combined into a large pools of data that many application programs access. An example is an employee database that consolidates payroll, personnel, and job skills, master file, etc. Then data sharing. Integrated data are more easily shared with authorized users. Databases are easily browsed to research a problem or obtain detailed information underlying a report. Minimal data redundancy and data inconsistencies. Because data items are usually stored only once, data redundancy and data inconsistencies are minimized. Data independency. Because data and the program that use them are independent of each other. Each can be changed without changing the other. It's not one-to-one dependent. This facilitates programming and simplifies data management. You can insert, delete, nothing happened to another set of data. Cross-functional analysis in a database system, relationships such as association between selling cost and promotional campaign, advertisement cost, right? Those are also you can develop some relationships. Can explicitly define and use in the preparation of management reports. You can see the importance. The importance of the good data. The company sent half its mail order catalogs to incorrect addresses, then what will happen? You send your promotional campaign incorrect email address, then all emails bounce back to you. Or the message what you want to send to the customer or potential customers, you can't get, you can't achieve the work. Having correct information in the correct places, in the right places, for right time, if you use, you can get massive advantages. Today, you know, the database management is very popular. There is a concept called, maybe you have heard about that, data warehouse. What is it? A data warehouse is one or more very large databases containing both detailed and summarized data for a number of years that is used for analysis rather than transaction processing. It's not unusual for data warehouses to contain hundreds or thousands of terabytes of data. You can see the data warehouses do not replace transaction purchasing database. They complement them by providing support for a strategic decision making. There's another concept people call business intelligence, BI. The analyzing large amount of data for strategic decision making is often referred to as business intelligence, BI. It's a large databases you analyze for decision making, strategic decision making purpose. The relationship among the data is there in the data warehouses, huge data is stored. Large databases containing both detailed and summarized data in data warehouses. 1,000 terabytes or a million gigabytes. That is the place, the data warehouses. Now this business intelligence, BI mean such a data you use for a strategic decision making, find out the new market, new customers, new segments. There are two main techniques used in business intelligence, BI. One called online analytical processing, OLAP, online analytical process. Second one is data mining. Online analytical process, OLAP, is using queries to investigate, hypothesize relationship among data. For example, a manager may analyze supplier purchases for the last 3 years, followed by additional queries that drill down to lower levels by grouping purchasing items number by physical period. What they have purchased, what time they purchased, all based on their information queries, they can go down the systems and even custom how much spend, whether credit card, whether cash, everything you can do. Online analytical processing. Data mining is using sophisticated statistical analysis, including artificial intelligence techniques, AI techniques, such as neural networks to discover unhypothesized relationship in the data. Unhypothesized relationship. We don't assume anything. Unbelievable thing you can get from data mining techniques to statistical techniques. For example, credit card companies use data mining to identify usage patterns indicative of fraud. Similar data mining techniques can ideate previously unknown relationship. Not the OLAP, you can use known relationship, hypothesized relationship. You assume something, whether it's true or not, you have to find the data and find out. But in data mining, unknown relationship, because you never thought about such a things happen. Unknown relationship in sales data that can be used in future promotions. Just an example, it's a very popular one. It's a popular one. Proper controls are needed to reap significant benefits from the data warehouse. Data validation controls are needed to ensure that data warehouses input is accurate. Verifying the accuracy, called scrubbing the data, is often one of the most time-consuming and expensive steps in creating a data warehouse. It is also important to control access to data warehouse as well as to encrypt the data or source stored data. Finally, it is important to regularly back up the data warehouse and store the backups. These things, in practically happening everywhere. Then database users and designers, they use two concepts called logical and physical views of data. Very important. In file-oriented system, programmers must know physical location and layout of records. Study rule is your files. Like counting system file or modeling files you have. Suppose a programmer wants a report showing customer number, credit limit, and current balances. Very easy. You can trace from the file physically, easily you can locate. To write the program, she must understand the location, the length of the fields needed. This record position. 1, 10 for customer number. And format of each field, right? Numeric or numeric sometimes both together. Process becomes a more complex if data from several files are used. Two concepts are very important. A logical layout, record layout is a document that shows the items stored in a file, include in the order, the length of the data fields, the type of data stored in an accounts receivable file. See, in accounts receivable file, there are so many accounts. There are outstanding balances, customer name, addresses. Those also records. Record is a document that shows the items stored in a file, all customer outstanding information, including order and the length of the data fields, technical how many fields. So all data is stored in the fields. Right? Record should have a fields, right? That's how much of field, length, and all sort of information. Record system. Database system overcomes this problem by separating the storage of the data from use of data elements. All data in a one block can be mixture, therefore they divided into the two mechanisms. The database approach provides two separate views of the data, the physical view and the logical view. Physical view you can see the views. Different users of the database information are at external level of the database. These users have a logical views of the data. An internal level of the database is a physical view of all the data, which is how the data is actually physically stored in the system. See, I can explain further. The logical view is how people conceptually organize and understand the relationship among the data items. For example, a sales manager views all custom information is being stored in a table. Customers outstanding amount, the sales manager can see. The today's orders, right, which customers already placed, sales manager can see as a list. So logical instructions you have to systems. The physical view refers to the way data are physically arranged and stored in the computer system. the user gets is what you want is a logical view. But in the system administrators, in database administrators, they have to store all this data into the system. Otherwise, this arrangement doesn't come. That is called physical view. Database management software, DBMS software, links the way data are physically stored with each user's logical view of the data. Want to get a logical view of the data, you have to physically enter the data into the system. That sort of work, database softwares are doing their job. The database softwares we call database management, DBMS, allows users to access, query, or update the database without reference to how or when data physically stored. Let's say you physically enter the data to the Microsoft Access database, and logically, if you want to see the way you want, whatever the way when the query is developed, right? Separating the logical and physical views of data also means that users can change their logical view of data without changing the way the data are physically stored. First, you enter the data in a systematic manner, the way they're given by the software. After that, logically, whatever the data, without affecting to the physically what you store, you can create, you can get. Maybe the list, maybe the balance sheet, maybe other things, easily you can retrieve, but nothing affected to the physical data view. That is the most important thing. Likewise, the DBA, database administrator, can change physical storage to improve the system performance without affect. These two are independent, without affecting the users or application programs. This is the design of database needs designers of database need to understand users' needs and the conceptual level of the entire database as well as database design. To design a database, you need to have a conceptual view of the entire database. Before that, there's another small concept you want to learn, that is called schema. SCHEMA, schema. Schema is a description of the data elements in a database. The relationship among them, logical model used to organize and describe. There are three levels of schemas. One is conceptual, external and internal. That shows the relationship among these three levels. Conceptual level, that is what first you should understand when you want to design the database. Conceptual view illustrates the different files, relationship among files. Conceptual, not empirically, kind of an assumption, conceptual assumption. My data relationship like that, I want customer name, those two relationships. So I want customer and his address, those two relationships. That's conceptually what you need from the database system as you conceptual level schema. The organization-wide view of the entire database lists all elements and the relationship among them. The external level schema is an individual user's view of portion of a database, each of which is referred to as a subschema. The internal level subschema, over level view of the database, describe how the the data are stored and accessed. Now, simply, I can show you this like a diagram. See the diagram. Suppose you want to see in your monitor, look the computer monitor, you want customer name, balances and outstanding days. And you want to know the sales of the region, like a pie chart or a graph. That's what we call logical view. What customer A and B wants, customer's information wants by some user, maybe manager. He wants to see the graph graphically, or he wants to the table what the user like you, person who sit on the monitor, in front of the monitor, what you want to look at, that is called logical view. In order to get this logical view, you have to insert the data to the computer. This is called physical layer. For that you need software called DBMS, Database Management Software. That user's requirement translate user logical views into instruction on which data should be retrieved from the database. So that you want software. Software, nothing, any kind of software, it works with the operating system. You can insert all softwares to your computer, but you need an operating system. The master operating system is a Microsoft. Apple company, they have Apple system. The operating system translates database management software request into instructions to physical retrieve data from various storage devices. Now you store the data physically certain places in your, can be cloud computing, virtual, some long period places, but operating system converted those data to operating systems and database software system to see something in logic. Now, in the users, external users mean the person who sit on the in front of the computer, look at the chart, look at the graph, now the chart, go to Google and download the document and see. Those people we call external level. Set of individual users logically views of a portion of the databases. You go to Google and find out. You go to YouTube and get some movies. You are external level user. To get such a thing, it should be there in the system. There should be a databases in Google. From that Google, they get the instructions to give such a things to you. Right? Otherwise, you can't see. Don't think you get something, nothing. No. You get something to see. It should be there in another system. Right? But those things are there in another system under the database operating systems. Right? Database software you need, right? Your computer should have operating system also convert to get that. The conceptual level means, say, what the information you want to see that is already stored with the kind of a relationship, kind of a mechanism into the database system. You have software called database system, maybe enterprise-wide view of entire data, maybe ERP, enterprise resource planning. This whole what you can see in front of your computer, that should be logically arranged. Conceptually, we have arranged and entered to the system. Then that is the first external level, then conceptual level. Then internal level means all data like inventory record, sales record, cash record, you enter detail wise, right? Details about the storage such as the data, layouts, definition, enter to the system and store. Those are the three levels to understand into the database design. There are so many database languages are there. Whole languages we can get together and call the data dictionary. The data dictionary contains information about the structure of the database. For each data element stored in the database, there is a record in a dictionary describing it. Database management software maintains the data dictionary, whose inputs include new, deleted data elements, and changes in data element names, description, users. Outputs include reports for programs, designers, and users, such as 1. Programs or report using data item, synchronize for the data elements in the file, 3. Data elements used by the users, whole things we have there. There are database management languages there. DDL, data definition language. Those are technical things all computer people know, but you just knowing like accounting people, it is important. Data definition language builds the data dictionary, creates a database, describes logical views for each user, and specifies records or fields security constraints. Data manipulation language charges database content, including data elements, creation, updates, insertions, and deletions. Data query languages, DQL, is a high-level one, like English language, contains powerful, easy-to-use commands that enable users to retrieve, sort, order, and display the data. Such a things also. Just understanding is enough for accounting. Relational databases. A database management software is characterized by a logical data model or abstract representation of database content. As most new database management softwares are relational databases connected to data relation. This means the focus primarily on database management systems. The relational data model represents a conceptual and external level schema as if data are stored into two-dimensional tables, like a tables. The data are actually stored not in tables, but in the manner described the internal level schema. It's like this. You enter the data like in Microsoft Access like a table wise, and then all these tables are joined together like a relationship by using primary keys and foreign keys. Then any person can develop a query and retrieve and see the what they want, the users want. Then relational data model means we enter the data like a tables. Each and every tables are linked together. That is called conceptual level. That is always without a conceptual level, the external users can't get the information. The internal level means we have to enter the data, into the table, right? Then all three, internal is into the data, and table are get connected, one table to another table, conceptual level, and these two are connected, what the external user want to see. Each row in table called tuple contains data about specific items in a database table. Each column contains data about an attribute of an entity. For example, each row in table contains data about a particular inventory item, right? And each column contains data with specific inventory attributes such as description, color, price. Similar, each row in a customer table contains data about a specific customer, and each column contains about the customer attributes, right? Such as name, addresses, etc. See, everything is row and column job. Right? Whole data in the world is row and column way. That is the way we can link each column, each rows to another table, column and row. Then that is conceptual. Right? Within this conceptual, you can develop various relationship models and you can see the data. Now, to link this conceptual level, table to table, we use a primary key. Very important. Here, conceptual view. Example, you can see customer name, sales invoice, right? Invoice that is column. Customers, sales invoice characteristics. Now row, D, G, each, everybody, every customer, sales invoice and invoice conceptual. Another table you have sales invoices. Another table you have invoice table. Linked together. A primary key is so many tables. We're going to link with one primary key to another table, another key is a foreign key. A primary key is the database attribute or a combination of attributes that uniquely identifies a specific row in a table. One row you mark as a primary key. Once you mark as a primary key in a table, suppose it's an item, number, as it uniquely identifies each merchandise items in that particular sales. Usually the primary key is a single attribute. In a tables, two or more attributes are needed to identify uniquely a specific row in table. The primary key of a sales inventory table is the combination of sales invoices and the items. You can see here the pattern is, you can see. A foreign key is the attribute in a table that is also primary key in another table. Say one table, primary key is another table, just the attribute, a row, this is the attribute in a row. That is we call foreign key. You need that, otherwise you can't link. The conceptual relationship you can't develop. The foreign key is the attribute in a table that is shows primary key in another table and is used to link the two tables. Customer table, right, is the primary key in the customer table. Foreign key is the sales table, right? In a sales table, customer number, customer table links sales to data about the customer who made a purchase, contain the customer. You can see his all information. Linking is that, right? So linking one, well, primary key. That's one you want to mention as a primary key. Once you specify another table, it should be attributes that call foreign key. Now these two tables you can link. You get the information what you want. That is relational databases. Designing a relational table, you won't store all data on a one uniform tables. That is foreign keys and primary keys you can see easily in this PowerPoint slide. Customer is a foreign key in a sales table. Right? Because it is a primary key that uniquely identifies customers in the customer table. Because of this, the sales table can relate it to the customer table. Customer table and sales table you can relate it. If we have one primary key in the one table, in another table you have to mention that one as a foreign key. Foreign key no need to mention, because once you have primary key, that same attributes you have to put it to the other side, that is enough. And in this table you can see sales invoice, right, and customer number. Now when you go to the second table, customer table, you have that customer number. Customer number in customer table you have. That is you have in the primary key of the, right, under the sales table. These are coming, right? These are very, very interesting things to understand. Now there are some kind of design in the relational database. Few concepts you want to learn. The store all data in one uniform table. Otherwise, a lot of redundancy issues can happen. Duplicating of data can happen. Now, this approach has two disadvantages. First, it stores lots of redundant data. Examine invoice several places. Same invoice. Likewise, inventory description in the several places. So such a problems you can avoid by using update anomaly, insert anomaly, and update anomaly mean improper database, not a good one. Improper database organization where non-primary key items is stored multiple times. Updating the item in one location and not the others causes data inconsistencies. Insert anomaly. Improper database organization that results in inability to add records to a database. Delete anomaly. Improper organization of database that results in the loss of information about the entire entity when a row is deleted. Now, these are the technical part. You have to eliminate it. You should want to reduce the redundancy of the relational databases. Very carefully you have to manage. You can see in this chart every column in a row in the row Right. Then in a databases, you can make more queries. Queries mean what you want, you can get. You can see in your monitor. You can retrieve the work. For that part, I think users may want specific information found in a relational database and not have to sort through all the files to get the information, so they query what they want, they can get. Example, you want one person's invoice number is outstanding, you can get. For that, always we link. Without table linking like this, we can't do such a job. That is what, in any queries you can develop like that. Those are the very important part of the database management. Then, queries are very important. I already mentioned the, the approaches to design and queries part. To receive, store data, use a query. Those are queries databases. If you want anything from the huge databases, according to your requirement, you can see. That part we call, this part you can't do without relational databases. Link data, table to another table and all kind of things. Then you can do such a things, you have to fix it under the relational, the conceptual part. How database system important to the accountant? That's part you should want to study. Database system have the potential to alter external reporting significantly. Considerable time and effort are currently invested in defining how companies should summarize and report accounting information to external users. In the future, companies may a copy of the company's financial databases available to external users in lieu of the traditional financial statements. Users would be free to analyze the raw data however they see fit. A significant advantage of database system is the ability to create ad hoc queries to provide the information needed for decision making. No longer is financial information available only in predefined formats and at specified times. Instead, powerful and easy to use rational database query language can find and prepare the information management needs whenever they want it. Relational database management systems can also accommodate multiple views of the same underlying phenomenon. For example, tables storing information about assets can include historical cost as well as current replacement cost and market values. Thus, managers will no longer be forced to look at data in ways predefined by accountants. Finally, relational database managements are capable of integrating financial and operational data. For example, customer satisfaction data can be stored in a database, giving managers richer set of data for decision making. Very important, you can see right now. This is a new information, historical cost. Nobody imported. They want to check historical assets values and all with the current market values. Those things you can table together and relationally you can show external users to understand. Even though our balance sheet we recorded in historical value of the assets, but today's current value is like this in another table. Relational database managements have a potential to increase the use and value of accounting information. Accountants must understand database system so they can help design and use the AIS, accounting information system of the future. Such a participation is important for ensuring that adequate controls are included in those systems to safeguard the data and ensure the reliability of the information produced. That's what we should want to understand carefully. Summary, right? Very important. As summary for today, you can understand that how all informations today is powerfully these databases make important, very important part in accounting today. So how data in the system, how data stored in the databases, you should want to know a little idea because whole accounting system is today systems are today computerized. Then how information they are in the computer system, the accountant must know that. That's the knowledge you should want to understand from this subject. That's enough for today's work. I will stop my video. Please study yourself further in this